Hello, my name is Tankoon Katunchaleekorn. My student ID is 63105508996. This is my student ID card. Okay, today I will be presenting to you mini project to sequential logic circuit design. The topic I choose is GCD Calculator. It is to find the greatest common divisors of two numbers. In this circuit, the user have to input in two number with the maximum of two digits. So the range of the number for each input will be from 0 to 99. Then the user can press the calculate button for the circuit to calculate the GCD values. And it will be displayed in 7 segments. The 7 segment will display both the inputs and the outputs, which the output is the GCD values. So let's look at the overall circuit first. First, in the input section, we use IC counter 74163 to control the input for it to count from 0 to 9 then go back to 1. We have here a NAND gate. In order to make the number when it counts to 9 go back to be 0, because 9 in binary system is 1001, so we connect MSB and the LSB with NAND gate and connect it to the clear of the IC counter. We use NAND gate because it is active low. Okay, next, for clearing number, the user have to input press the button, can be any button, this one N1A, N1B, N2A, or N2B. Then we connect all the buttons using OR gate. We connect and then connect it to the shift register. For here, the user have to press the button for 3 seconds. We connect it to OR gate. Then if we get the output 1, then we connect it to the shift register and to the clock. With the clock, it will make shift register from 000 to be 111. Then going to AND gate will make the output be 1. Then this is the clear signal. And clear will go to the every IC counters. We use OR here in order to make when we press any button, it will clear every input's number. Because if we didn't use OR gate, it will only clear the button that it will only clear the value of the the button that button, but other button will number will remain the same. Okay, now when we finish with the input, now let's go to calculate the GCD number. But before that, we have to prepare the number. To prepare the number, here we have to change the number to be on the 10 position and 1 position. Okay, so in here we the IC counter number 1 and number 3 have to connect to the multiplier to change it to be the 10 position, and then we use adder to add it with the second and fourth. 1 will be adding with 2 and 3 counter will be adding with 4. So now we get 2 number, and then we will assign in input A and input B. Okay, now we finished preparing the number to calculate. Now we go to calculate the GCD number. Okay. In this, we will go through the multiplexer, register, and then comparator. First, we input in the cal button. This will indicate that we want to calculate or not by pressing this button. Okay. We have to use the comparator here because we are computing for the GCD number using the Euclid formula, which we have to compare the number are higher or lower or equal. And when the number are equal, that number is the GCD numbers. And here we are using multiplexer to choosing the case. Okay, when we're pressing the calculate buttons, Q will be changed from 0 to 1 because of the T flip-flop. Okay, then then we send the signal to the register, and yeah, and it will go on. Okay, when we finish computing the GCD number, it's time to display the number. With here is our output display. So we using a 7 segment to display our output. Our 7 segment will show the output of the show both the input and the output. By this first two 7 segment will be displaying the first number. Then the third and the fourth 7 segment will be displaying second number and also the GCD number. Okay, we also construct this IC 7447 in order to connect it to the 7 segment to display the correct number. And this is our truth table of IC number 7447. Okay, this is how the circuit looks. This is when we connect it with the 7 segment, the IC. Okay, now it is about the flashing effects, turn on, turn off of the 7 segment. In here, when you when you finish inputting the numbers, both number, then you press the calculate button. First, the 7 segment will display the input number for 1 second, then disappear for 1 second. After that, the 7 segment will the two 7 segment at the top will still show the first number, but the third and the fourth 7 segment which show the second number will switch to show the GCD number. Okay, then it will show it for 1 second, then disappear again for 1 second, then loop and go back to show the first number and second number, and then show first number, the GCD number, and then repeatedly with this until we will clear our resets. Okay, and to construct this circuit, we use multiplexer. And we have to separate the top one and the bottom, because the bottom have to add more multiplexer because it have to choose whether to display the second number or the GCD numbers. Okay. Okay, now that we know roughly how this circuit look like, let's build it. We'll be adding 4 buttons. Okay, we will set it as first N1A. Second one is uh, uh, N1B, and the third one N2A, and the last one is N2B. Then we add in our IC number 74163. We add in 4 of the IC counter. Okay, we connect our button to the IC counter. Okay, next we connect 4 input of the 7 six of IC counter 74163 to the ground, and connect the to I connect the upper input with power. Uh, Next, we connect the NAND gate with our IC counter. Okay, okay. Now this is our input section. Okay, okay. Next, let's go to the clearing, the value clearing. Okay, let's move a bit. First we connect all of the button with OR gate. Okay, next we connect it our OR gate with a shift register. Okay, we select a stage to be 3. Oh, same. Uh, what's this? Uh, why change to blue? Why? Uh, okay, now let's add a clock. Okay, I save this first. Let me restart it. I think some problem may occur. Okay, it's back to normal. Okay, and we add in a tunnel. No, okay. Now we get the output of the shift register connected with the AND gate. Okay, when we click a button for 3 seconds, uh, the 000 on the chip register will change to 1. Then we put it to the clear of the IC counter. Okay, next we add in a OR gate. We add in OR gate because to make when we press one button, it clear all of the numbers in every number in 7 segments. Because if we do not use the OR gate, it will clear only the number that the button are pressed and the rest will not clear. So we use OR gate here. Okay, and this is our clear signal. Okay, now let's go to our GCD calculate number. In this, we will change the number to be in here we change the number uh, to be on 10 position and 1 position. Okay, okay. First, we add in splitter. Connect the first one to the LSB, the 0. Okay, connect the first one to the LSB and the and the number 3 to the MSB, and the rest of the splitter we will connect it to the ground. the blue Y appear again. Okay, restart the program. Okay, now it's fixed. Okay, okay. The first one and the third one of the output of the IC counter is the 10 position of our numbers, our input numbers. Okay, then we connect the output of the 10 position with multiplier. Okay, we use two multiplier. Okay, then we connect it with the pin. Okay, okay. When we finish multiply in with 10, we plus with our second we plus we use adder to add the number together with one position numbers. Okay, then we add pin to check our numbers. Okay, we'll be adding a tunnel. Okay, first and name it as input A. The first one is the number of the number of the input number in 1A and in 1B. Okay, we name it input A. The second one we name it as input B. It is a number in N2A and N2B. Okay, now we are ready to calculate the GCD. we already prepare our numbers. Okay, next we will be finding our GCD numbers. Okay, first let's add our calculate button. Okay, where is this? Okay, then we connect this calculate button with T flip flop. And also connect it with clear. Okay, this cal will control the multiplexer. Okay, next we add in a multiplexer with one select bit and 7 data bit. Okay, then we connect input A and input B with our multiplexer. We connect it that if we didn't press the cal button, multiplexer will show this input to be the output. Okay, next we will add a channel name mode. Uh, okay. Okay, then we add in a register. Okay. Both of the register will be using the same clock as below, and also with clears. Okay, now we take the output of the register and connect it to the comparator. Okay, showing the data bits. Okay, okay, and we add in a subtractor. Okay, we add in a subtractor to choose which case will be happen. We have here is higher than and lower than. We call for equal it will be separately, not using a subtractor. Okay, then we add in another multiplexer. Uh, okay, connect our the subtractor to the multiplexer. Okay, okay. Then we uh, connect the output of the multiplexer to another multiplexer. Okay, now let's go to the equal cases. Okay, we add in our Okay, get in there or would be if we get equal, we will get input B, so we connect it with the multiplexer to choose B to be the output. Okay, then we connect the output of the multiplexer equal multiplexer to the dividers. Okay, so we divided by 10 to separate the number to be on a 10 position and the 1 position by having a decimal to separate the numbers. In this program, in this circuit, it will at the end we get equal because we are using a Euclid to find the GCD. Okay, after we connect to the divider and we connect our pin to the divider also. Okay, then we connect it to a 7-bit splitter. We will not be using our first 4-bit. The upper will be, as I say, the upper will be the 10 position and the RAM will be the 1 position. Okay, we connect it to the channel and name it as the first one, the 10 position. So the multiple you name it, the first one the multiply 10 and the second one the multiply 1. Okay. Okay. Now let's build this playing output. But first, we have to make our IC 7447 first. Okay, okay, we add circuit name. 7447. Okay, we add in our input. Oh, sorry. And we add outputs corresponding to the 7 segments. Okay, now the truth table appears. So let's fill in the truth table. Okay, the last one are 0, because to close the 7 segment display. The rest don't care. Okay, let me reshake a bit. Okay, let's build circuit. Okay, so this is our IC 7447. Okay, next we will add the IC 7447 to our main circuit. Okay, and add in 7 segment, and then we connect the outputs of this 744 IC 7447 to our 7 segment. Okay, now that we finished with our IC 7447, let's get to the last part, the flashing effects of 7 segments. Okay, about the display on the 7 segment to make it appear and reappear, appear, disappear, and reappear with the frequency. Okay, so first we will insert splitter. Let me link in the Y for a bit. Okay, then we insert splitter. Okay, then we will add in a multiplexer to select the signal. Okay, we also connecting this pin to the multiplexer. Wait. So when the pin 1010 mean to close all of the display for the input. Okay, and we use mode as our selector. If we didn't press the count, mode will not active and will be choosing to display the input. Okay, and then next, okay, For the flashing effect, we will connect it to another multiplexer. N1A and N1B will be separate with N2A and N2B. Because N2A and N2B have to display the GCD number also. Okay, but let's do with one N1A first. Okay, then we add another splitter to connect to our 7 segment. Okay, then we have to add clock and mode, and together for uh for the flashing effect on and off to be displayed. Okay. Then we connect it to all of the multiplexers. Okay. For the for the into A and into B, we have to add another multiplexer because we have to choose to display the second input number or the GCD value. Okay, then we set this clock to 2. Okay, we get this the 10 position connect to the multiplexers. Okay, then we connect using splitter to connect with the our 7 segment. Okay, it's error again, I think. Sorry. Okay, let's reopen it. Okay, let's connect it again. Okay. Okay, let's try the circuit. Okay, first we have to tick enable for clock to work. Okay, now let's try. Oh, well, it doesn't show arrange the number. Okay, let's see why. Okay. Okay. Oh, I forget. Oh, I forget you. Okay, connect this multiplexer and this. Okay, the value still not arranged. Okay, let's look at a second. Oh, here. Okay, let's delete this. Uh, okay. Oh, I also forget to rearrange this one, the bits. You have to rearrange from 0 to 3 to 3 to 0. So this change the 3 to 1 and 0. Here is 3 2 1 and 0. Also here 3 2 1. And 0. Okay, and set this to be 1 0 1 0. Okay, so here. Okay, now let's try it again. Okay, so number are already arranged. Click the number, increase the value. 3, 4, 5, 6, 7, 8, 9, and then okay, back 0. First, second, okay, third one, fourth one. Okay, so the number here is don't have any error anymore. So let's try to find the GCD values. Let's find for the number 60 and 36. So if the program will run properly, they will be getting 60 and 12. Okay, let's click calculate. 60, 36. Okay, now 60, 12. 60, 36, 60, 12, and 60, 36. Okay, now let's try to reset. Okay, we click. Okay, I try to click the first button. Okay, the barrel are reset back to 0. And this is the total equipment we are using. Okay, thank you.